Good morning. Today we are going to see the NPTEL assignment number 2. Now in this we have first question, number of independent equations to be satisfied for the static equilibrium of a plane truss is 3, because we have 3 equations of equilibrium. We have Fx0, these are independent, Fy0, and third we have moment 0. So these are the 3 equations which we have for trusses. Choose the correct answer for the following. Now we know this as a frame. So we have formula ds, that is equal to 3n plus r minus 3j minus rr. Now m we have 3, r we have 4, j we have 4, and rr we have 2. So we get ds equal to 3 into 3 plus 4 minus 3 into 4 minus 1, and then we will get 0. So statically determinate and stable, we have answer is A. In first case we have answer as B, here we have A. Now in third we have this as mechanism, because we have this is no truss, no frame, and then we will have D, that is mechanism. Then a statically indeterminate structure is the one which can analyze C. So we have already seen in the class that is can be analyzed using equations of statics and compatibility equations. So we have answer is C. Then we have the number of force members or null members, zero force members or null members in the following truss. So as we know, as there is no reaction, no external force, so at this joint, and therefore we have both members are 0. Now here we can see we have 3 members, no force, no reaction, so these 2 are collinear, this becomes 0. As the joint we have same situation, these 2 are collinear, so automatically this becomes 0. So we have 4 members where we have forces at 0. So we have answer that is A. Then force in member CF. So we are going to take cut in this fashion. And if we will take cut in this fashion, then what will happen? So we are going to get diagram in this way. So just consider only that portion that is left of this. We are considering left of this, we have this as D point, 10 kilonewton is acting over here. So this is D. Now this is 4 meters. Then we have 10, 20 kilonewton over here. And then moment about D, then these 2 members which are cut will pass through D, becomes 0. Moment 0 about D. And then we have due to 20 kilonewton 4 meters. So this is anti-clockwise. To balance it, force in this should be clockwise, and for this one we have should be arrow towards right. Now this will be force in FC. Now we have to find this distance. So we can have this distance. So now this angle we have 60 degree, because all sides are given 4, 4, 4. So it is equilateral triangle. And so we are going to get this distance as 2 meters. So we will get this vertical distance, and that is equal to 4 sine 60. This is 4 meter. And then if we will consider this triangle, so we have this as 4 meter, this is 60 degree. Then if you will write sine 60, then we have y upon 4. So y will be 4 sine 60. And then we will write equation moment about D equal to 0. And then we will get it as minus 20 into 4 plus FFC into 4 sine 60, and that is equal to 0. And therefore we will get value of FFC, which should be equal to 23.09 kilonewton, and that we will get it as tensile, and we have option for this is C. So question 6 we have option C. Then we will switch over to question 7. So we have to find force in member BC. So for BC we will take cut in this fashion. Then how we will get this, or better you can find reactions also, that will becomes easy. So we will find vertical reaction at this. So we will take moment about A0 and let this reaction will be By. So we have actually due to these forces we have clockwise. So this reaction should be downward, gives us anti-clockwise. And then we can have this as minus By into 2 plus 10 into 6 due to this. Then plus 10 into 4 due to this second 10, and plus 20 into 2 due to this 20, and that is equal to 0. And from this we will get this value as 20, then 20, 40, and this 30, 70. So we have By 70. Now if we will consider this joint, so we have horizontal also here, and that horizontal will be 10, 10, 20, 40 kilonewton. But we are interested with vertical. As this is downward, so we are going to get this is upward, and this will be equal to 70 kilonewton. So we have 70 kilonewton tensile. So 70 kilonewton this one. And if we will consider this joint, then we have this as 70 kilonewton downward, and this reaction we need not require actually, which will be 40 by summation Fy. So this we will get it as 70 kilonewton, and therefore this is FBC, and that will be 70 kilonewton tensile. And then we have to find FDE. So we will take this cut, and then we are going to get this in this fashion. So we have this 10 kilonewton, and then this also we have 10 kilonewton. So this vertical member, this member. So we will have this, if we will extend this, then this will meet at point C. So I will mention it as C dash. And due to these forces, we have clockwise, so it should give anti-clockwise. So FED, and then we have minus FED into 2 plus 10 into 4 plus 10 into 2. And from this we will get FED, that should be equal to 40 plus 20 by 2, 30 kilonewton, and as value plus, so assume direction is correct, compression. So 70 tension, and next one is that is DE compression. So we have answer for 7, that is B. So we have this answer as B. Then we have this 8th question. So now in this we have to find force in CH and CF. So CH and CF. So we will take cut in this mesh. Now as it is symmetrical truss, so reaction will be half. So we have this reaction as 15 kilonewton, and we have this reaction also 15 kilonewtons. And then we will consider right part only. So we will get right part in this fashion. So we have this as 15 kilonewton, and then we have two members at this joint. So we have this member as F. And now first we will find force in this member. Now 3 members are cut, but out of these 3, these 2 are passing through F. So we will take moment about F. So we have 10 kilonewton over here. So if we will take moment about F, Then we have due to CH only moment about F and this 15. So 15 will give anti-clockwise. So it should give clockwise. Now if we will find this angle, then we are going to get this angle that is equal to 26.57. Now how we have calculated this angle? So we have drawn a line linear to this. Sorry, connecting this. So this is 1 meter. So total we have 3 out of this. This is 2 meter and this is 2 meter. And this angle will be theta. So we will have tan inverse tan theta that is equal to 1 by 2. And from this we got this value 26.57, which is 0.5. So 26.51 we have, and now we will take moment about this, and we have two component. One will be horizontal, another will be vertical. And vertical component will pass through F. So we have to consider only horizontal, which component will be cos. So we have F CH cos 26.57, and this distance is 2 meter. We have this distance also 2 meter. So moment about F equal to 0, and then we can have minus FCH cos 26.57 into 2. Sorry, this is clockwise, so plus minus 15 into 2 equal to 0. And if you solve this, you will get value of FCH that is equal to 16.77 kilonewton compression. And then we have to find that is FFC. So let us we will consider tensile FFC and then apply summation Fy0 for this. Then we will have minus. So now we have this as 16.77. So we will directly take 16.77 sine of 26.57 minus 10, which is acting at joint H. Then we have plus 15, and then we have to find FFC, and we have this sine of. Now you calculate this angle, which will be tan inverse. So this angle. So we have 3 by 2. So alpha, if I will say, then tan alpha that is equal to 3 by 2. So that is 1.5. And this angle comes 56.31. This is 56.31. So we have sine 56.31, and that is equal to 0. Gives us value of FFC that is equal to 3 kilonewton tensile. So we have option 3 kilonewton tensile, 16.77 compression. So we have option D. So remaining two questions we will see in the next video. So thank you.